Today I'm going to demonstrate some of the powerful capabilities in the Apprenda Cloud Platform, specifically as they relate to Kubernetes, microservices and cloud-native applications, and containers. Now to get started, you're going to need a Kubernetes cluster. If you don't have one or need help installing one, Apprenda provides the Kismatic Enterprise Toolkit. It's a fully open source installation tool, configuration management tool for Kubernetes clusters. So it'll help you set up a Kubernetes cluster quickly, and it also automatically bakes in a lot of the best practices that we've learned through work with our enterprise customers. I've already set up my Kubernetes cluster, and you can see the dashboard here. And the first thing I'm going to do is actually hand this cluster over to the Apprenda Cloud Platform. Now, why would I do that? The Kubernetes dashboard is great, and managing Kubernetes clusters through the dashboard is a great experience. But one of the things the dashboard doesn't do is separate the concerns between operators and developers. You can see nodes, you can see apps, you can see all the application artifacts. But enterprise IT customers want to be able to provide Kubernetes capabilities as a service back to their developer community. They see themselves as a service provider. They don't want to just hand developers clusters with Kubernetes nodes and applications. They want to offer that back. And that's what Apprenda helps enterprise IT do. So if I go over to the Apprenda Operations portal, first thing you'll see is that I can actually view the infrastructure in my environment. Now what I have in place already is a set of Linux servers and a set of Windows servers, right? And these happen to be running existing Java and .NET applications, your traditional legacy applications. And Apprenda helps you cloud enable those applications to make them more scalable, more secure, and generally more elastic or cloud friendly. In addition, Apprenda helps abstract the infrastructure. You can run the Apprenda platform on the infrastructure of your choice. That's physical, virtual, private, public, hybrid, and we have a policy engine that allows you to automatically determine which cloud an application is supposed to land on. Policies that can arbitrate the allocation of those infrastructure resources. But your apps themselves become completely infrastructure independent. So you see I have these Linux and Windows nodes here. What I'm going to do is go ahead and add that Kubernetes cluster to this environment. So I'm going to give it a name. Type in the URL, authenticate to the cluster. Now to save myself some typos and typing, I'm going to go ahead and cut and paste my file that I have here. This heapster URL allows us to surface more granular performance and utilization information. So if I go ahead and save that, what the Apprenda Cloud Platform does is validates that the cluster is working as expected and runs a bunch of diagnostics against it. So I've added that cluster to my environment, and now if I go and look at the infrastructure panel, what you'll see here is that I've got those Linux and Windows servers, but I've also got this large Kubernetes cluster that's now available to host applications. You'll also notice that I have a database nodes section that's listed here as well. And the database nodes, you'll see SQL Server and Oracle. Now Apprenda supports a wide variety of databases, but if you happen to be using SQL Server or Oracle, there are additional capabilities that we provide that allow developers to consume the database as a service as well. So there's additional capabilities. You'll see that come through in the demo. Before I go ahead and open up the platform to allow developers to deploy pods and microservices and containers, I want to be able to set up some policies. And I'll show you just some of the policies that are available. So you see here that I've set up a resource policy. There are two resource policies in this case. One is called the Kate's small pod, which allocates about 0.3 cores and 1,000 megabytes of memory. And you can see that applies to pods. You can set policies for all different app components that Apprenda supports, and that includes UI components, Linux services, Windows services, Java apps, traditional .NET apps. You can be very granular with how these policies can be applied. So I've set up a resource policy that developers will be able to attach to their pods, and I can customize this menu, create as many or as few policies as I deem fit. Another powerful capability is the ability to add custom metadata to application objects as they're deployed. So customers will want to be able to attach custom configuration data that might be necessary to integrate with their other systems, that they'll want to be able to retrieve these properties either programmatically or through the GUI. So you see here, I've created a piece of metadata called business unit. It applies to applications. These are the allowed values. I have a default set up. And then you can see that I've made this property visible to devs, and developers are able to edit this property. Right? And you'll actually see that when I log in as a dev, I'll be able to interact with this metadata. Now that metadata is powerful, but it also allows us to drive a feature that we call bootstrap policies. And what bootstrap policies allow the service provider or central IT to do is to interrogate and modify the application and application components being deployed to the platform before they're actually deployed. So if you want to be able to scan a Docker file, or you want to be able to scan a pod spec and modify it in some way, add an APM tool for monitoring, change security configuration of ports, change the base image that's being used, you want to make those types of transformations automatically, you can inject bootstrap policies that modify that workload and that payload before it gets deployed. And that allows you to control the types of containers that get deployed on the platform. One of the concerns that enterprise customers have is that by opening up a container platform for developers to use, they'll lose control over the types of applications and the configuration of those applications that are being deployed, and that might open themselves up to security vulnerabilities down the line. And so this again helps you put those speed bumps or those controls on this container highway that you're building, so that the traffic and the applications can continue to function safely and securely. All right, there are many more configuration and policy constructs you can create through the operators portal. I won't show all of them to you today, but the one powerful thing I should point out is that the single platform, the single Apprenda platform, is going to host both legacy as well as modern cloud native applications all in one place. And that means you can apply these policies, these constructs in one spot and have them apply to these mixed era applications. So if you're struggling with trying to figure out what to do with those legacy apps and how to manage them alongside your modern microservices cloud native apps, well, Apprenda provides that solution by giving you a single control plane. Okay, so that was the operator story, which is interesting, but of course the most powerful part of this is actually the developer story. So now I'm going to switch hats and play the role of the developer. So this is the Apprenda Developer portal. Now, as a developer, I don't want to have to deal with infrastructure, with nodes, with load balancers, networking, and storage, and all of the details of how my applications actually run. I just want to work with my applications themselves. And the first thing you see here is, in fact, your list of applications. And in this particular case, as a developer, I have two legacy apps that Apprenda has actually cloud enabled. The first one is a traditional .NET application. It's a three-tier IIS, WCF, SQL Server backend application that's running on platform called Timecard. I also have a Java application that's currently running on the platform. And this is another application that would have predated cloud native and containers. It simply runs on Apache Tomcat. So I've got those two existing legacy apps running, but now I want to be able to deploy brand new cloud native microservices container-based applications. So what I'm going to do is create a new application, and this application happens to be an Nginx container. It's just an Nginx instance. So I'll upload my YAML pod specification for that specific Nginx pod. And before I get into the details of configuring this, I'll just show you what I actually uploaded directly. There's nothing fancy. It's a replication controller where I've defined 3 replicas of an Nginx image that I'm pulling from Docker Hub. So it's something that you would typically hand to a Kubernetes cluster to define a pod definition for your application. So now that I've uploaded this YAML definition, I can go ahead and configure how I want this application to work. So one of the things I can do, if you recall, I'd set up that custom property with metadata called business unit. And now as a developer, I can go ahead and edit this. Say if I'm with equities, go ahead and save that. That metadata is now tracked with my application. And remember, this metadata can then be used to drive policy and governance and compliance features on the back end. But as a dev, I don't need to worry or be concerned with that. But the fact that I've typed in equities might actually change how my application gets deployed. It might impact the type of environment that my application gets deployed into, say private cloud, public cloud, and it might actually even change the composition of the app. So that would all happen transparently for me as a developer. The other thing I can do is assign those resource policies that you saw me create earlier as an operator to this particular application. So by default, I got the Kate small pod policy. If I want some more juice, I can go ahead and pick a different policy and confirm that and get the SLA that I want. And Apprenda will track the resource utilization. So if you want to feed this into chargeback or showback systems, that's possible as well. So that's it. I've handed a definition of the container that I want. Now I want to go ahead and deploy it. So I'll click the promote button. And now what Apprenda is going to do is actually create this pod, deploy it on the Kubernetes cluster that backs this Apprenda Cloud Platform instance, and it's going to automatically set up the appropriate routing, load balancing, ingress rules so that the application can actually be accessed outside of the cluster with the URL. So there's a lot of stuff around Kubernetes that you need to understand in order to get this application to run in that manner, to have it externally accessible to the cluster in a scalable way. All of that is abstracted by the Apprenda Cloud Platform. So it's really simple. You hand us a pod spec, or your CI/CD solution hands us a pod spec, and we spit back a URL that you can use. So my app got deployed. You can go ahead and go back, and if I go ahead and open a new window and actually try to hit the Nginx server, you can see that I actually have access to the Nginx server that was created there. Now, one of the other things that we've done with the Apprenda Cloud Platform is made it really easy to centralize how logging works for developers as well. So in this case, this Nginx server, which is running 3 instances, you see the 3 different pods that have been created, because that's what I defined as being required for this application. I can also centralize getting logs out of those containers. Because remember, as a developer, I don't have access to the actual nodes. I can't remote into those machines, but I want access to all of those logs. Right now, the platform is by default only set to show you logging if there are errors, right? So if I want to be a little bit more verbose, I can create what we call a log override and ask Apprenda to show me everything that's also debug or info level. So now when I go back to logs and turn on some real-time streaming for the log, if I go to my Nginx server and start hitting refresh and hitting with some traffic, you'll see these info log entries start to show up, right? And that's Apprenda centralizing this log information. This is also forwarded to platform operators so that they have access to these logs. In addition, logs can automatically be forwarded to third-party log aggregation systems, like Splunk, or if you're using an Elk stack on the back end, for example. So those are all standard features in Apprenda to make it really easy to manage logs. We also have the ability to handle log grooming policies. You can automatically prune logs after a certain amount of time, set retention periods, all of that stuff. In addition, we have an audit trail that's created as well that's forensically consistent. And what the audit trail allows you to do is ensure that if the system is compromised in some way, you have a read-only view of all the transactions that have happened in the system over time. So that was a really simple application. Now let's try to deploy something that's slightly more complicated. What I'm going to do now is actually deploy a multi-component, multi-tier app. In this case, it'll actually be a .NET Core MVC application that is going to talk to a SQL Server backend. So go ahead and give my app a name, and I'll upload the artifact that I want to deploy. And in this case, you'll see that it's actually a zip file. It's not just a YAML file because it actually contains multiple artifacts. Let me actually show you what's in this package here as well. So this application that I'm deploying now has multiple components. There's a persistence tier, which is my backend provisioning script for my database. And you can see here that this application will actually, part of this application, Apprenda will provision a database and a database table as defined in this script. This is really important because if you want to provision and connect to a database as part of a distributed application, it can be more complicated than it otherwise might seem. You need to be able to securely authenticate to that system, which typically involves passing secrets and tokens. If your application moves between nodes, as it's going to do, and in a dynamic container environment, you need to make sure you maintain connectivity. There are a wide variety of considerations. Also, your database teams, especially in the enterprise, may not be so eager to run their database within their database platforms within containers, certainly on day one. And so as a developer, you also don't want to package the actual database engine within your application component either, because that would cause a massive proliferation of database instances within an organization that operationally and security can cause problems, but also licensing considerations come into play. So with Apprenda, you don't actually have to package the database as part of your app. You simply ask for a database instance from the database service that's provided by the platform for either SQL or Oracle. If you look at this particular pod, this MVC application, you can see that it's actually pulling an image from my Docker Hub repository. And in this particular case, the database connection string is not required to to be provided by the developer. The developer simply says hashtag application connection string, and then Apprenda will automatically wire the real-time connection string at deployment time into the application's environment variable, bind it to the application itself so that it can maintain connectivity to that database. So it's really simple. If you want to connect to a database, simply provide a hashtag token in your config file, and Apprenda will wire it in for you. It's really that easy. I can do all the same things with this application that I did with the previous Nginx deployment. If I go over to the Scale tab, I can apply policies. This app now has more than one component. It has a database component here, so I can give my database component some resources. It has a pod, which is the MVC application itself, the business logic. And then I can assign a storage quota. In this case, I have one. So this can help limit how storage is consumed on the database backend as well. So this is really great if you're working with DBA teams who want to offer the database cluster that they currently manage as a service back to a platform like Apprenda. Go back to the dashboard, and again, I'm ready to deploy this application. I simply click promote, and it'll go through the exact same process that it went through with the previous Nginx deployment, except in this case, an actual database will get created, the environment variable will be token swapped, the application will be connected to that database, and I'll be ready to go and ready to be able to use my application. And you can see all of that, including the database creation, happens in just a few seconds. So now my app's deployed, and I can go ahead and launch and start interacting with this application. Again, a rather simple app. And I think it does lazy instantiation, so it may take an extra second here for it to start up on first access. But again, as a developer, I didn't have to understand or know where my database resides. I didn't have to understand Kubernetes in detail and how Kubernetes applications are supposed to connect to databases. I simply deploy my app and have Apprenda do all the heavy lifting for me. And this app is a really simple database entry application. Put in some values for this and hit create just to make sure it's all working correctly. And you can see that it is. So I have that legacy .NET application that predates any of this cloud native container stuff. I have a modern MVC .NET Core application. I have an Nginx server. And I've only, obviously, this is just the tip of the iceberg. You can run a wide variety of applications on the Apprenda platform, whether it's cloud native or whether it's a legacy application. And as a developer, if I have a cloud native application that needs to talk or interact with one of those legacy applications, the fact that they're sharing a platform, the fact that databases and services provided for me makes it really, really simple. I don't need to be a distributed systems expert to understand how to use this stuff and get it working. Now, the other thing we mentioned that was powerful is that for operations teams, you get a single control plane for all of your apps, both legacy as well as cloud native. The dev team I happened to be logged in as was called Acme Corp, and you can see those 4 apps that I was working with as a developer. The WCF and Java legacy apps, as well as the Nginx and MVC core application that I have. So if I go over to the Nginx application, you can see that I have those 3 instances of Nginx running. I get more details around which actual server those application components are running on. I get that infrastructure insight that's not available and shouldn't really be available to the developer community. So really easy to get centralized access to this stuff. And of course, if I were a developer and I wanted to scale this application, all of those scaling operations that you expect to be able to happen in your environment are all directly available here. So if I want to scale the number of pod instances I have on an app, I simply hit the slider, hit scale. Really easy. I don't have to understand replication controllers and details and how that works with Kubernetes, although that is what we're using on the back end, right? So this is all ultimately calling a set of REST APIs against that Kubernetes cluster that you saw me set up earlier. And that Kubernetes cluster that I set up, it's important to point out, is not proprietary in any way. That's a pure upstream open source Kubernetes cluster. That is not an Apprenda proprietary distro. Right? You can just pull that up off of an open source repo. In fact, if I go over back to this Kubernetes cluster, you'll see that Apprenda has actually created a namespace called ACP, and that's where we deploy all of our artifacts into, right? So all of the artifacts that are created as part of an Apprenda deployment are all located here. And you'll see that the number of pods on that MVC app now are up to 3. You'll also notice that all of the labels and all the properties that we define as part of the app are set up as labels within Kubernetes. Again, that's all very, very transparent. This isn't a black box. This is fully available for enterprise IT as well as developers to look at. And that's by design. We also log all of the REST API calls we make against the Kubernetes cluster to make it really easy to understand how Apprenda is interacting with it. So as lock-in and those types of things are concerns in the enterprise, we want to be very transparent and simply provide a set of simplified developer workflows and a service provider model on top of Kubernetes, rather than trying to replace it with a proprietary set of components. And that's basically Apprenda and Kubernetes and Cloud Native in a nutshell. There's much more to learn. If you go to apprenda.com, there's lots of great information there with more detail on any of the topics that were covered today.